Power rules review. If you're in my class tomorrow, you have a quiz, but this power rules review is going to cover multiplying powers, dividing powers, what happens when you have a zero or a negative exponent, and then raising a power to a power and then a product to a power. So when we're talking about multiplying powers, we can combine things that have the same base. If you remember, the rule for multiplying powers is to leave the base alone and to add the exponents. So when we have this first example, 2 squared times 2 to the third, the base 2 is going to stay the same, and we're going to add 2 plus 3, which is 5. So 2 to the third times 2 squared times 2 cubed is equal to 2 to the 5th power. If you wanted to, or if you were asked to simplify this, you could multiply 2 times 2 times 2 times 2 times 2, or 5 2's together to get a number as your answer. In the next example, I'm multiplying two powers that have the same base. In this case, my base is n. I'm going to leave the base n alone and add the exponents, so I get n to the 13th power. And the final example on multiplying powers is a little bit more complicated. If you notice, we have two coefficients or whole numbers, 4 and 3. So I have 4x squared, y cubed, or y to the third, times 3x to the fourth, y to the 8th. I can combine things that are alike. Because I'm multiplying these, the whole numbers, 4 and 3, I'm going to go ahead and just multiply them. 4 times 3 is 12. And then I can combine the x squared with the x to the fourth and the y cubed with the y to the 8th, which gives me 12, x to the 6th, y to the 11th. I get 12 by multiplying the two coefficients or whole numbers. 4 times 3 is 12. I get the x to the 6th because I leave the base x alone and I add the exponents, which for x were 2 and 4. 2 plus 4 is 6. And then for the y's, I leave the y base alone and I add 3 plus 8, which is 11. When I'm dividing powers that have the same base, I am actually going to end up subtracting the exponents. It's always the top exponent minus the bottom exponent. So for the first example, r to the 5th divided by r to the 3rd, I'm going to have r to the 5 minus 3, which is 2. So my answer is r squared. For the x to the 9th divided by x to the 4th, I'm going to subtract the exponents, 9 minus 4, and I'm left with x to the 5th power. And then for the last example, I have 3 squared divided by 3 to the 4th. Remember, it's always the top exponent minus the bottom exponent, and in this case, I have 2 minus 4. Well, when you do 2 minus 4, you end up with a negative 2. So I have 3 to the negative 2nd power. We're about to talk about this, but if you remember, you could actually rewrite this using a positive exponent by putting 3 squared under 1. Which would give you 1 over 3 to the positive 2nd. And you could even take it a step further. I don't think I did here, but you could even take it a step further and go ahead and do 3 squared, which means 3 times 3, and you could write this as 1/9. Zero exponents. If you remember, anything to the 0 power except for 0 is 1. So if you have 0 to the 0 power, it's going to be 0. But 7 to the 0 power is 1. Negative 400 in parentheses to the 0 power is 1. And then this last one is a little bit different. B to the 0 power is going to give you 1. And I need to multiply 1 times 2 to the 3rd. Well, 2 to the 3rd, or 2 cubed, is 2 times 2 times 2, which is 8. So I could have 1 times 2 cubed, which is the same as 1 times 8, which is 8. When you have negative exponents, and again, I'm not going to spend a ton of time on this because I kind of already went over it, but to write a negative exponent as a positive exponent, you have to put it under 1. So b to the negative third is the same as 1 over b to the positive third. 7 to the negative second is the same as 1 over 7 squared. And then 2 to the negative fourth is the same as 1 over 2 to the positive fourth. When you have a power to a power, your problem is always going to have parentheses around the power, and then right outside of the parentheses, you're going to have another exponent. So if you look in parentheses at the first example, I have b squared, and then right outside of the parentheses, I have this raised to the fourth power. When this is the case, you go ahead and multiply the exponents. So this is going to be b to the 8th. The next example, 4 cubed times raised to the 5th power is going to be 4 to the 15th. If you look at this n to the 9th and then to the 0 power, if you remember 9 times 0 or anything times 0 is 0, which gives me n to the 0 power. And I know that anything to the 0 power is a 1, so I can actually just go ahead and put a 1. On the next example, I have c squared in parentheses, and then cubed, and that's in parentheses again, and then to the 6th power. What you do here is you go ahead and you multiply all of the exponents together. So you get c to the 2 times 3, which is 6, times 6, which is 36. And then in your final example on this slide, we have r to the 4th, to the 2nd, and then raised to the 0 power. If you remember, anything raised to the 0 power is always going to give you 1. If you multiplied these together, you would have 4 times 2, which is 8, but then you have to multiply it by 0. So you would get r to the 0 power, which I can just write as 1. And finally, we need to talk about product to a powers. If you notice inside of the parentheses in these examples, I have a multiplication problem. So in the first one, I would have a squared times b to the 3rd, and then that's in parentheses, and that's all being squared. What you do is you kind of take the exponent on the outside of the parentheses and you distribute it to every factor inside, and you're multiplying the exponents together each time. So the two factors in the first example are a squared and b to the 3rd. Go ahead and bring the squared that's on the outside in to both of those, multiplying each time, and you get a to the 4th times b to the 6th. In the next example, your two factors are 3 and x. When there's not an exponent, remember it's an understood 1. So 3x in parentheses to the 4th would give you 3 to the 4th times x to the 4th. We can go ahead and simplify 3 to the 4th, and that is 81. So I would have 81x to the 4th. The next example, I have 5x cubed in parentheses and then squared. Going ahead and distributing the squared to both factors inside, I would have 5 squared times x to the 6th, which is the same as 25x to the 6th. If you look at the last example, there's two different ways that you could go about solving this, and each one should give you the correct answer. You can actually go ahead and use the multiplying powers rule for everything inside of the parentheses. So you have y times y squared times y to the 3rd. Remember, if there's not an exponent, it's an understood 1. So you could add the exponents 1 plus 2 plus 3, which would give you 6, and then multiply that by 4, which would give you y to the 24th. So I used exponent rules because they're all y to a power. I can go ahead and use the first rule that we talked about, which is adding the exponents, and then leaving that in parentheses and keeping the 4 right outside. Very similar to the last one, I could go ahead and do a to the 1st times a squared times a to the 3rd, and which give me a to the 6th. And then it's raised to the 0 power. But if you remember, anything to the 0 power is always going to give you 1. So your answer here would be 1. Those are the product rules that are, I'm sorry, the product rules. Those are the power rules that we've talked about so far, and those are the power rules. For a more in-depth look at each rule separately, you can go and find, I have a video for each rule separately. This is just a review of all the rules in one place if you just need a quick refresher. So to see them explained a little bit better or a little bit more in depth, you can go find the specific rule that you need explained.